Minasan, konnichiwa. In this video, let us talk about the next module about level of exit discharge, or LED. Now, there are several LED in different engineering disciplines, and specifically, we are talking under Life Safety Code in NFPA 101, LED's level of exit discharge. This is your professor, Dr. DrEYPEI Zantua. I'm a civil engineer, electrical engineer, mechanical engineer, production engineer, instrumentation engineer, industrial engineer, and a PhD graduate. I am an alumni of Polytechnic University, Japan, that graduated BSME as a Japan government scholar. So let us proceed with our topic, LED. Let us start first with the main objective of the code. The Life Safety Code addresses specific requirements to minimize danger to life from fire, smoke, heat, and toxic gases, mission continuity and property protection in both new construction and existing building. So we are on part 2 right now, and currently discussing about hazard of contents. So under this topic, we are on the second subtopic, level of exit discharge. Okay. So let us discuss an important paragraph in this code. It is actually a new one for NFPA 101 year 2018. This is 3.3.88.1. It states that the story that is either story meaning floor. Okay, when we say 3-story, 3 floors. Okay, so story is either number 1, the lowest story from which not less than 50% of the required number of exits, and not less than 50% of the required egress capacity from such a story discharged directly outside the finished ground level. So that is what we mean by level of exit discharge. Okay, it is the floor. The level of exit discharge, it is the floor. Okay, it is either first floor, second floor, third floor, and so on. Depending upon the name of the floor, the level of exit discharge is that floor, which is the lowest floor from which not less than 50%. How can we understand it? These expressions easier. No? We can understand it by looking at the antonym. Not less meaning more. Not less is more. Okay? So the lowest story from which more than 50% of the required number of exits, right? More than 50%. And more than 50% of the required egress capacity from such story, right? Will discharge directly outside, okay, at the finished ground level. Okay, so finished ground level, where it came from. The discharging came from what? What number of floor? And that number of floor is what we call level of exit discharge. With these conditions, there are 2 conditions: more than 50% required number of exit, and more than 50% required egress capacity. Egress capacity is the number of people that is estimated to use that exit. Okay, for example, the number of occupants is 200, and there are 2 exit. So you can design it such that 100 will go to one of the exit, and the other 100 will go to the other exit. Okay, so therefore, in that case, it is actually equal to 50%. Okay? Okay, for example, one is exit going to the second floor and another exit is going to the ground floor, and therefore that is 50%. And that is not more than. But take a look. Take a look. Take a look. What we have in our code is not less than. Not less than, the opposite meaning is more than. How about equal? Equal is also not less than. Okay? Okay? So therefore, actually, if you invert this statement, not less than 50%, it is actually equal to or more than 50%. Because 50% is not less than. Okay? It's 50% is not less than 50%. Okay? So equal to 50% or more than 50%. So in that case, my stated example satisfies this egress capacity and also satisfies the number of exit condition because there are two required number of exit, and one of which is utilized in one floor and the other is on the other floor. Now, therefore, one of the floors is 50%, exactly 50%. It is not more than 50%, but it is equal to 50%. Okay? So, therefore, take note that the statement not less than is actually equal to the statement equal to 50% or more than 50%. Okay? So it's clear. This is one paragraph which must be satisfied. If not, or we can satisfy the next one, the next paragraph, because the condition in 3.388.1, either, the word here is either. So it is either this one, this item number one, or the next item. So where is the next item? The next item is number 2, where no story meets the conditions of item 1. Okay. If there are no floors that meets the condition of item number 1, the floor that is provided with one or more exits that discharge directly to outside to the finished ground level by the smallest elevation change. Okay. Less than 50%. It is not satisfied. But because there are no other floors that satisfies that condition, item number 1, we can use this item number 2. Let us look for the floor with smallest elevation change from the finished ground level. Okay, so finished ground level outside has the smallest elevation change. Why? Because it has the easiest way out from the building. Okay, that's why we can consider it as a level of exit discharge. Okay. And let's have an example. Number 1. This picture depicts a 4-story building. So 4-story meaning 1, 2, 3 floors. There are 4 floors. Okay. The finished ground level. So this is the finished ground level. Here is the finished ground level as the arrow indicated. Finished ground level here. Finished ground level here. As you can see, there are 2 exits. Okay. So the finished ground level varies little in elevation from building side to side. Okay, meaning they are on the same, they are almost on the same grade, same elevation. Okay, Okay. Therefore, in that case, the first floor is the lowest floor from which not less than 50% of the required number of means of egress and not less than, okay, take note, it is easier to understand. The first floor is the lowest floor from which 50% or more of the required number of means, and that is correct, that is satisfied, and 50% or more of the required egress capacity from the story discharge directly outside the finished ground level. And because that is the case, we designate that floor as the level of exit discharge. Okay. Next example, number 2. This picture depicts a 4-story building, the same 1, 2, 3, 4. But now, as you can see, there are 2 exits on different floors. One for the first floor and one for the second floor. And as you can see, the finished ground level varies in elevation from building side to building side. So the elevation here is on the same level as second floor. The elevation here, a ground level elevation here is on the same level as the first floor. Okay, that is the difference. Now, well, which one is the level of exit discharge, the first floor or the second floor? Let us proceed with the explanation. Both the first floor and the second floor are stories, are floors from which not less than 50% of the required number of means of egress and, okay, 50% and more of the required egress capacity from that story discharged directly. So both of them, okay, could be, okay, because they both satisfy, okay. The definition of level of exit discharge directs the code to designate the lowest exit or the lowest floor as the level of exit discharge. So if there are 2 floors with the same condition, the lowest floor would have been the one to be selected. Okay, so the first floor would be the level of exit discharge. Example number 3. This picture depicts a 4-story building, as you can see, 1, 2, 3, 4. But now there are 3 exit, one from third floor, one from second floor, and one from first floor. So there are 3 exit. Okay. The finished ground level varies in elevation significantly. 3 of the floors have exit discharging outside. So from using stairs, from ground level using stairs, and from second floor, this is the elevation, and we'll just go there. No, it can either go there and go here. That is the elevation. So it is this second floor is the exit which do not utilize stairs in going outside of the building. Okay. So yeah, after going outside of the building, you have to use stairs. After going outside of the building, you have to go by use stairs. So therefore, which one is the level of exit discharge? Let us explain. 3 floor, the 3 floor, it has means of egress of 3 equally sized exit stairs. So therefore, they are recognized as exit discharge because they are exit stairs and enclosure doors are there. So there are enclosure. Okay, so it's not, we did not see in the picture, but in the for the exit to be considered as exit discharge, this exit should have enclosure. Okay, enclosure. Okay, so enclosure doors, and each of them, each of the exit provides equal or more than 50%, okay, of the required number of means of egress discharging from the floor. This is not satisfied. This is not satisfied because there are 3. And there are 3 of them. So 100% divided by 3, that is 33% for each of the exit discharge or the egress. 33%, though, that is less than 50%. Though, that's why the item number 1 is not satisfied. And then, therefore, we have to use item number 2. So, in item number 2, level of exit discharge is that exit discharge story with the smallest elevation. Okay? Elevation change needed to reach the finished ground level. Okay? Or the ground level. Okay? So we can see, finished ground level, which one has the smallest elevation change? Second floor. It doesn't have elevation change actually. It is on the same level with the finished ground level outside the building. Okay? Where here, there is use of stairs, so the elevation change is clearly observed here, also here. So therefore, we can what? Choose the second floor because it is discharging directly at the finished ground level and therefore must be classified as the level of exit discharge. Unlike the first and third floor that require travel over stairs to reach the ground level. Okay? Okay. Note, again, we have here a picture with the finished ground level, which use underground. And then from the underground level, we have first, second, third, and fourth floor. So which one is the level of exit discharge? Level of exit discharge. We have the underground level, also have the same level as the finished ground level. Although it is underground, there is a what? Provision on the ground, on the earth, on the soil that levels in the same level as with the exit from that underground. Same with this, no? Same level, same level, same level, because there is a what? Soil topography that looks like this, okay? There's a soil topology, okay, like this, okay? So, how can we determine the level of exit discharge? For low occupancy ancillary spaces with exit doors discharging directly to the outside. So it is discharging directly to the outside, such as mechanical equipment rooms or storage areas. So that is the case here. This is a mechanical equipment room. It doesn't usually have an occupant. We want to save lives. Okay? Okay? We want to minimize danger. Okay? We want to minimize danger to life from fire. Okay? We don't prioritize saving the mechanical equipment. And that underground level is not usually for occupants, but for storage of mechanical equipment. Okay? And similar storage areas that are located on levels other than the main occupiable floors should not be considered in the determination of LED. So it is not considered. We can only consider the ground floor here, the first floor. Okay. And that would be our last page. Thank you very much. Again, this is Dr. DrEYPEI, preaching engineering for nation building.